Okay, this is section 3.9. It's chapter 3, mechanics. I forgot to record this question. I'm just gonna solve it now because I think it's very important, come on. You have an Atwood machine made of two blocks of masses 50 grams and 300 connected by a light inextensible string, passing through the groove of a massless and frictionless pulley. The heavier block is placed on the smooth inclined plane at an angle of 37 degrees with horizontal UG equals 9.8. So, since they're mentioning that it's a smooth inclined plane and they didn't give us any coefficient of friction or didn't even ask for friction, you're going to assume that there's no friction, okay? Here, when they say inextensible string, this is the first thing you write on your written if you get it. Inextensible string, it means two things, okay? T1 is equal to T2 and A1 is equal to A2. Okay, so we want to calculate the acceleration of the blocks. Okay, obviously 300 grams is the heavier one, so it's going to pull 50 up, right? طيب, let's see. We're going to draw both FPDs. We're going to start with 300 grams. Let's call this mass 1 and we're going to call this one mass 2, okay? For mass 1, what's the FPD going to look? Always, and I start by drawing the y-axis. Okay, wait. I always start by drawing the y-axis like this. The y-axis and the x-axis, right? طيب, and then I draw my forces. Obviously, my weight is going to be perpendicularly downwards, and my normal is always perpendicularly upwards, right? As I know, my weight is not perpendicular, sorry, it's just vertically downwards, but the normal is the one that's perpendicular. Okay, anyway, so I'm going to rotate this now and put it on the side. So mass 1, the FPD, how's it going to look? It's going to look like this. Y-axis, x-axis. The weight is on the left side, so I'm going to put it like this. Let me change color. Weight is going to be on the left side like this. The angle between the weight and the vertical is 37 degrees. Okay, we have the normal push upwards. And what else do we have? We have the tension pulling it to the right, yeah? So we're going to call this T1. Okay, obviously we're not allowed to keep the weight like this. Obviously, guys, vector simple, so we're not allowed to keep the weight like this, so we're going to dissolve it into Wx and Wy. This is for M1. For M2, M2 is very easy. I also forgot, one second. Thank you, Leighton Nasser Alan, for pointing this one out. You always, if you have your acceleration, you know which direction is accelerating, put the direction of the acceleration, okay? Write it on the side. For M2, it's very easy. You just have, we don't have any horizontal forces. I can just draw the y-axis like this. And we know that there's two forces. There's the weight and there's the tension pulling it up. There's no normal because it's not attached to a surface. It's pulled by a cable, okay? So let's draw it. I'm just going to draw the vertical side, okay? So this is the y-axis. Let me draw the weight, obviously going down and up. We don't have normal because it's a string, huh? It's tension. Let's call this T2. طيب, now let's see. For M1, sigma of x is going to be equal to mass times acceleration. It's called M1A. Why? Because it's accelerating down horizontally, right? Is it not accelerated? It is. So it has to be equal to MA. What are my horizontal forces? We know it's accelerating down to the left. So Wx is going to be bigger than T1. So we're going to say Wx minus T1 is equal to MA. What's M? The mass is 300 grams. So 0.3 kilograms times the acceleration. Okay. We'll substitute later. Sigma Fy here. It's going to be equal to 0. Why? Because is it jumping up and down? No, right? Our block, is it going up and down? No. So it's going to be sigma Fy equals 0. So Wy is equal to N. Always, these steps, you do them all the time. Here, we don't have any Fx, so we're just going to say sigma Fy, right? Here, what happens to the cable? It gets pulled up, it accelerates up, so it's going to be equal to MA. You ask yourself, is it accelerating or is it not? Sigma Fy equals MA, so that means it's accelerating up, so T2 is greater than W, so T2 minus W is equal to M2A. Let's start substituting. Okay, we know T1 and T2 are equal, so we can just replace it with T. Okay? Type. Wx, what's Wx equal to? It's equal to the weight, mg, times sine of the angle 37. صح? Minus t is equal to 0.3a. Okay. Here, we don't really need it now because we're trying to find acceleration. T minus w is equal to m2a. W, in this case, is equal to m2g, right? Equals m2a. Okay, now substitute the mass. Our mass here is 0.3. Our g is 9.8. minus t is equal to 0.3a. Here, substitute the mass. It's 50 grams, so it's going to be 0.05 times g, which is 9.8, equal to, again, the mass, 0.05 a. Now let's simplify. 0.3 times 9.8, you get 2.94 minus t is equal to 0.3a. Can we find an expression for the acceleration? Yes, it's equal to 2.94 minus t over 0.3, right? Just divide by 0.3. Here, in this case, can we find an equation for the acceleration? Yes, just divide by 0.05 on the other side. But before I do that, let me just get rid of this, clean this up. Multiply 0.05 times 9.8. 0.05 times 9.8. I got 0.49. So t minus 0.49 is equal to 0.05a. Divide now by 0.05 on both sides. You're going to get that a is equal to t minus 0.49 over 0.05. Now I have two expressions for a. Can't I just equate these to each other? Yes, I'm going to take this a bit up. I'm going to get the 2.49 minus t over 0.3 is equal to t minus 0.49 over 0.05. If you have a calculator that can solve equations, you can do this on your calculator. Oh, why did I put 2.49 with it? It's 2.94 here. My bad. 2.94. Okay, 2.94 minus x over 0.3 equals x minus 0.49 over 0.05. Shift solve. You get the t is equal to 0.84. Okay, so tension is equal to 0.84. So we actually found part B. And we want the acceleration, so you can just substitute t equals 0.84 to any expression for acceleration. So let's substitute it into here. A is equal to 2.94 minus 0.84 over 0.3. So go 2.94 minus 0.84 over 0.3. You get 7. So the acceleration is equal to 7 meters per second squared. Let's check our answer. That is the same answer I got. Yeah, I get why I got it wrong. I forgot to multiply by sine 37 over here. So let me just repeat the steps again. My bad. Let me take this back here. Forgot sine 37. Let me erase this. Multiply by sine 37. 0.3 times 9.8 times sine 37. You get 1.77 minus t equals 0.3a. And now just solve normally. Take 0.3 to the other side. You can get a is equal to 1.77 minus t over 0.3. Now, if you solve this equation, if I use this and equate it to this, I should get a correct answer. So a, we have two expressions for a. This one's normal. There was no angle. So this is normal. And the way I solved it was fine. But here I just forgot sine 37. So equate it to each other. A is equal to a, right? We have two expressions. So 1.77 minus t over 0.3 is equal to t minus 0.49 over 0.05. You get your calculator. You get 1.77 minus t over 0.3 equals t minus 0.49 over 0.05. Shift solve, and you get so you get t is equal to 0.67. And then if you plug in t to the acceleration, you can find the acceleration, right? So a is equal to 1.77 minus 0.67 over 0.3. 1.77 minus 0.67 over zero point 0.3, you get 3.67. So A is equal to 3.67 meter per second square. I think this was the answer. This was in the solution. 3.66. Okay. And T is 0.67. Yes. There you go. So obviously, guys, in the written part, and I just did this because I'm recording, okay? But if you have this in written, please make sure you actually solve this. Like, do cross multiply, show the person correcting it how you solved it. Cross multiply, do 0.3 into t minus 0.4. You know how to distribute this into this and then equate it. You solve math, عادي. You know what? I'm just gonna. Are we past 8 minutes? Oh, it is. Okay, you know, خلاص, I'll just do it. If you were to cross multiply, you're gonna get 0.3 t minus 0.49 equals 0.05 1.77 minus t. Okay, if you distribute 0.3 into 0.49, you're gonna get 0.147. It's gonna be 0.3 t minus, because 0.3 times minus 0.49 is 0.147, is equal to 0.05 times 1.77. 0.05 times 1.77, you get 0.0885 minus 0.05 t. And I think everybody knows here how to solve this equation. You take 0.05 to the other side, becomes 0.3 plus 0.005, 0.05. You get this t, you get this, and then you add 0.147 on the other side. So 0.147 plus 0.0885 divided by, we had 0.35t, so divided by 0.35, and you get this. Okay, so I think you all know how to solve an equation. It's pretty straightforward. And then you take this value and substitute it into the A. Okay, that's it for this one, for this question. Thank you so much for watching. Good luck.